online lecture series for software engineering KCS 601. Myself Dr. Inderjit Kaur, Associate Professor in the Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. In the previous lecture, we have discussed about the last phase of SDLC, that is the software maintenance. We started with the need of software maintenance and we covered the types of different software maintenance, how we can do. Then we have calculated the cost of software maintenance. It covers the 70% of the software maintenance cost that we have seen. The various models for software maintenance cost estimations have been studied. One of them was B. Boehm and then Behman and Larry. Then in this lecture, we will be discussing about the various parameters for calculating the cost estimation. These parameters, they are the cost, effort, how we can schedule the project, what will be the duration of the project. So, this lecture covers the calculation of these parameters being used for cost estimation. So, what is software cost estimation? Predicting the cost of resources that are being required for the software development process, that is known as the software cost estimation. Here we are talking about the financial terms. So, the what financial money we are spending in the terms of effort to develop and to test my software, means in the entire SDLC, what are the efforts, what is the time spent in doing the development of the software, that is known as the software cost estimation. So, cost estimation for the project, it is done using various approaches. Either we can apply some mathematical algorithm or we can do using some parameters and apply the equations. These approaches, they are termed as the cost estimation models. So, here we will be discussing the parameter first and then we will be moving on to the cost estimation models like COCOMO, COCOMO 2 and then Ratnam Putnam model, etc. Then let us discuss about the software. It is just like doing a risky business. If we study the British Computer Society survey, we will come to know that there are only 130 projects they were successful once they have started with the 1027 projects. So, only 130% they were being delivered in the real life. So, delivering all the system requirements within budget and within time, keeping the project quality in mind, that is what is delivering the software. That means, we want to implement all the SRS requirements within time frame, within given budget, and we should not compromise with the software quality. So, this is all about doing the risky business, that is developing the software. Then out of these delivered projects, we will come to know that only 70% they gets completed and rest 30% they do not get completed. There are several reasons. The reasons may be any. Why they are not being completed? Either the staff have left, either the requirements they were not feasible, either the cost estimation was not done proper, either they are failing in testing, either they are not being able to maintain themselves. There can be n number of reasons ki why they are not being completed, and then if they are completed, then why they are not being residing in the market, because they are not able to maintain themselves. Then 53% of the project cost, it is almost 200% of the original estimates. Some of the software, they suddenly increase their maintenance cost. It becomes around 200% what was the original estimate. Why it becomes so high? Was not it being studied properly in advance? How it is rising actually at the last phase, that is the reason. So, in 1995, as per survey, around $81 billion they were being spent on the failed US project. So, how you can see ki how much disaster has happened, how much amount of big money it has gone to just water. So, all these surveys project, they were following the waterfall life cycle. It may be the reason ki the development life cycle model that we have selected, that was not proper. We should not select that. The reason can be any, I told you, but the ultimate is ki the software is getting failed. It is just a risky business. We cannot say ki once we have developed the software, it is coming to in the market, it is getting launched in the market. It can be failed even after being launched in the market. The reason can be it is not able to maintain itself. The company standards, they have changed, persons they have changed, language, operating system they have changed. That is the reason we have spent a lot of lectures in studying the software maintenance, ki how much important is our software maintenance. Only doing coding, only doing testing, they are important for development, for launching, but how we are maintaining our existing things once they have been launched, that is much of important after the development phase of our software. Then yearly cost estimation, as we have said ki we are doing the cost estimation in the earlier phases, and then in the practical life scenario that cost is becoming so high. And is it the reason ki cost estimation cannot be done exactly at the earlier phases of software? The answer is yes. The cost estimation, it is needed early for the software pricing. We are determining the software price as summation of two terms, that is cost and profit. Here we can see from the previous data slide ki 70% of the projects they are getting completed and 30% they are not being completed. The reason is the software price is being increasing, or they are not able to maintain themselves. Then once we are entering into the software cost estimation zone and various other parameters, let us discuss first the terminologies that we are going to use. What parameters we will be selecting for doing the maintenance cost estimation of a software. The first parameter is effort. If we define the term effort, it is the amount of effort required to complete an activity. How much time I am spending? Time means I am here talking ki how many persons they are going to finish one task in how many days. So, the unit of effort, it should come in person month or persons day. If we are talking it in a week, so persons week, persons month, and so on. How much effort, physical effort is being done to complete an task. Then the second parameter is my duration. Duration means how much calendar time is required to complete an activity within the resources assigned. So, if we am talking about the duration, that means I am talking about the time. Let us the developers, once they are designing the software, so they keep in mind ki I have to deliver it in a hour. I have to in a team we have to do this task by this end of this day, or by end of this week, or by end of this month. By end of this year, this software will be getting launched. So, this planning is required. That planning means that is done in terms of duration. Duration stands ki how much time I require. It may be in the terms of hours, day, week, month, or year. Then the third parameter is the cost of an activity. What is the amount that I am going to pay if this activity is being done? If I am purchasing any software, how much amount I am going to pay? That is, what is the total cost of an activity? Project estimation and scheduling, how they are being interleaved? They are known as my maintenance activities. Then coming to the different software components, the first component is effort cost. So, here effort cost means it is one of the dominant factor in mostly all the projects, means how much amount I am going to pay to my employees of any software organization in the amount of salaries. Then how much social and insurance and other benefits they are being given to my development team, to my testing team, that is they all are counted under effort cost. Then the second thing, the second component, it is my tools cost. Tools cost means here I am talking about the hardware and software that is being required for the development. So, it is I also know that depreciation on relatively small if I go in other next coming years. Then travel and training cost, I have to, when I am counting the entire software cost, I have to count in these parameters, means I will be counting how much is my effort cost, how much is my tools cost, how much I will be spending in travel and training, how much will be overhead, then that will give me the cost of tentative cost of my software, and then I will add some my profit of the organization, and then it will give me the tentative view of software cost, how it is being estimated. So, the for different clients the travel and training cost is being given. Then the overheads, overhead means I am here including the cost of building, cost of AC, heating, lighting environment, cost of doing networking, cost of doing communications, cost of shared facilities, depreciation cost and some activity based cost if it is required during the maintenance of the software. Means once I have delivered some project to any company, to third party customer, some activities, some installation, some shared facilities, some networking has to be done to maintain that environment, to maintain that working environment for that software. So, that are counted as overheads. Then here I can determine the software pricing factors. The different pricing factors, they are being influenced by the economic considerations, they are influenced by the political consideration and business needs. Here suppose I calculate the software productivity now. So, it will be calculated in terms of rate of software production. Here the rate of software production means I am calculating in the terms of needs for measurements. So, measurement measuring the software produced per unit time, that is what are the lines of code per hour they will be executed, means that will give me the idea of software production rate, and then the software is produced including documentation. Then this productivity measure, it is not the quality oriented actually. So, although quality assurance is a factor in the productivity, but we are not counting it. Then next is the size related measures. Size related measures, it focuses on the sum output from the software process, and here we are telling the number of lines of codes that is being delivered, the lines of code existing in my source code. Then my next parameter is function related measures, that is based on estimate of delivered software functionality. It is counted in terms of function points, it is counted in terms of object point, it is counted in terms of UCP. Then which problems that we are facing, that is measurement problems while doing these cost analysis. The first problem is estimating the size of measure in my product. Then estimating the total number of elapsed programmer months, suppose a programmer has left, or estimating the contractor productivity, that is done by the documentation team, or incorporating the estimate overall estimate. So, these problems had to be tackled. Then determining the lines of code, program length. Actually, this lines of code is the length of my source code that is used to predict my program characteristics. It is calculated or it is measured in the terms of person month, effort and ease of maintenance. This lines of code, it was firstly proposed when we are programming on the cards with one line per card. We started with writing on the cards, then we started with the high level languages. Then its usage, it corresponds to the statements, as suppose we are talking in Java, it spans to several lines. Lines of code means what is the program should be counted as a part of the system, what programs to be counted, and for those programs how many lines to be counted. It assumes the linear relationship between the size and volume of the documentation. Then our next parameter is the function points. This function point, it is being used in two ways, first in the past and how much we require in the future, that is to develop the metrics from historical data and use of available things to size the software for a new project. So, based on the combination of program characteristics, it is counted as the figure of these parameters. Firstly, we will say ki what are our EI, means external user inputs, that is input transactions that update my internal files. Then is EO, external user output, coming in terms of reports and error messages. Then is my UI, interface, user interface, in the form of inquiries. Then next is my logical internal files that are being used by the system, and the last is my EI, that stands for external interfaces, that is what are the different files that are being shared with the other system. Here I assign the weights to these parameters. These weights vary from 3 to 15. 3 is given for simple project and 15 is for complex, they are being associated. So, then I calculate the function point by multiplying each row count what a program is having with its weight, and then I will be summing all the values. This slide shows the calculation of function points. Here I have taken these all the measurement parameters that I have discussed, number of user inputs. How many number of user inputs I have, I will count them in my program. Suppose I have 10, and this is the simple, average and complex weighing factor of a program is being given. Suppose a program is very simple, so these weighing parameters will be considered. If it is intermediate, then the averaging parameters will be considered, and if it is too lengthy and complex, then these weighing parameters will be considered. Then suppose a program has user input 10 and it is very simple. So, here we will multiply 10 cross 3. As I said, the program is simple. So, it will be simple for all the measuring parameters. That means the number of user outputs, suppose they are calculated as 8. These are the examples I am taking. So, 8 will be multiplied by 4, 32. Then the number of inquiries, suppose there are 5 inquiries. So, 5 cross 3 will be 15. So, here I have taken the simple program. Then the number of files, they are suppose 2. So, here I will be having 14. Then number of external interfaces, suppose they are 10, then here I will get 50, 10 cross 5. So, I will do the count, that is coming out 4 and 5 9, 9 and 2 11, then 7 8 9, 9 and 5 141 count is given. then I have some complex multiplier given in my program. So, after dividing that I will be getting my FP. These are the functional points complexity that I told. There are 14 factors. Each factor is given on a scale of 0 to 5. Suppose backup and recovery, then data communication, distributed processing functions, performance critical, existing operating environment, online data entry, input transactions, master files updations, then complexity of input output files, complexity of processing, code design, then our installation included, multiple installation and application design to facilitate. These are the parameters for deciding the complexity of a program. They are being scaled from 1 to 14. So, here I will use this formula. FP is equal to UFC, UFC stands for unadjusted function point, into 0.65 plus 0.01 into the summation of all FIs, 1 to 14 that I have discussed in the last slide just, where these parameters, the value of these FI, it can range from 0 to 5 because I have scaled them 0 to 5. So, the advantages for FP, they are very available early, they are not restricted to the code, they are not language dependent and they gives accurate results than lines of code. Then disadvantages, they ignores the quality, they are subjective counting, they need to be automated. Then there are two kinds of models, static and dynamic. Static using single variable and dynamic means all the variables they are interdependent and there are no basic variables. So, here I am going to take two examples, one is using LOC approach and next one is using function point approach that we have just discussed. So, assume a program that is estimating the lines of code in the project as 33,200. Then the organizational productivity for the similar project type is given to me 620 lines of code per person month. Then the burdened labor rate is also given to me $8,000 per person month. Then I need to calculate the effort, the cost per LOC and then I have to calculate the total cost of my project. So, this is how I am going to calculate effort. Effort will be calculated as total estimated project divided by the organizational productivity. It is calculated as total estimated project LOC divided by the organizational productivity. This is the formula for calculating the effort. So, this effort according to this formula it will comes out to be 33,200 divided by 620, that is 53.6 means 54 persons are required per month. Then the next parameter, cost per LOC, this cost per LOC will be calculated by dividing the labor rate divided by my productivity. So, it will be around $13 per LOC. Then the software total cost of the project, it comes out to be 8,000 into the number of effort I am going to calculated that I have. So, 8,000 into 54. So, these are the total cost of my project using LOC approach. Let us take the second example that does with the FP approach. So, using this FP approach, here I will do the apply the formula UFC into 0.65 plus 0.01 into summation of Fi, where I goes from 0 to 5. So, this UFC is given to me 342 in the program, and this I have calculated, that comes out to be 0.65 plus 0.01 into 52. This 52 is coming from summing of all the 14 values that are being given for calculating the function points. So, it comes out to be 0.65 plus 0.52, that is 1.17. So, 342 is given to me into 1.17, that gives me 400. So, the complexity adjustment factor that I calculated using the summation and weights of Fp, that is 1.17, and from that 1.17 Fp comes out to be 400. So, this was all about the estimation of different parameters that were being used to calculate the cost estimation. Thank you.